Hello everyone. Now we're going to talk about the PN junction. So recall last time that we have discussed the P-type and N-type semiconductors. So for the P-type, this is characterized by holes from the addition of impurities such as arsenic. So these holes act as acceptors. So meanwhile, in the N-type semiconductor, this is characterized by free electrons, and these free electrons are actually donated, so they are called donors. So now we try to experiment what will happen if we bring close together a p-type semiconductor. So this is a p-type with its holes, and a n-type semiconductor. So here we have electrons 4, 2, 3, 4. Now I want you to understand that these two semiconductors are, of course, electrically neutral. So this means that the nuclear charge balances out with their number of electrons. So they are both neutral. But when you bring these two types of semiconductors together, what forms is actually really amazing. So these free electrons will want to migrate towards these holes. So what will happen now is we have the same p-type here, and we have here the n-type. So we still have our holes here, but since this electron migrated here, this p-type semiconductor, which is initially neutral, will experience a negative charge, while this n-type semiconductor, initially neutral, will now experience a positive charge. And around this region, around this junction, so what can we say around this junction? This has no what? No free carriers. Whoa. So there is no free carriers. So meaning if there are no free carriers, it acts as if it's an insulator. So there are no charge carriers capable of traveling in this region because all of them are situated in the valence bands, or moreover, all of them are already sitting in the valence band, and they don't want to participate in conduction. So if it acts as an insulator, how can it be useful in say in electrical equipments? So I'll draw here again P and N. So in this region we have our we will have an intrinsic electric field. So there will be a potential drop associated with this configuration. So let's try to connect a circuit in this PN junction. So first, let's provide a battery, a current in this direction. So what will happen is that this battery will drive the positive charges here. So it will drive positive charges, and since we have a depletion layer here, these positive charges cannot go around this circuit. So it cannot actually travel here and then complete the cycle. So there will be effectively no current. So let me write here depletion region. So there is no there is a depletion region here, and it is because there is an electric field that prevents this. Okay. There's an electric field that prevents this positive charge to pass through this junction. So what if we increase the voltage of the battery? And we increase it enough so that this electric field, by increasing the voltage of this battery, this electric field will actually die down. So how come does this electric field will die down if we increase the voltage?